Hello and welcome to this tutorial, where it's going to be the last tutorial on complex numbers before we move on to the actual lecture just outline. So complex numbers as they apply to real situations, real equations. So the first equation I'm going to write on the on here is x squared minus 4x plus 6, and let's say we'd have to solve it. Well, to do that, what we're going to want to do is we're going to use completing the square, because it's going to be easier this way. So we're going to bring this negative 6 over, and then negative 4 divided by 2 is negative 2. Negative 2 squared is 4. Add 4 to both sides, plus 4 equals negative 2. And then the resultant perfect square trinomial is going to be x minus 2 squared equals negative 2. Now when we take the square root of these two terms, suddenly we're taking the square root of a negative number, which we can do with I. It becomes negative 1 times square root of 2. So that's like I times the square root of 2, which is exactly what we're going to write. X minus 2 equals I times the square root of 2. But plus or minus the square root of I over 2. Because whenever you take the square root, of a number, it can be positive or it can be negative. So therefore, we get that x equals 2 plus or minus the square root of 2 over I, written in proper a plus bi format. And that's pretty self-explanatory. Now let's extend this definition to polynomial functions. Polynomial equations, because we can even use I in those situations. So let's say I have the following polynomial equation: y equals x cubed plus 8x squared minus 18x plus 20. Keep in mind, what makes a polynomial different from a quadratic is the fact that the leading term, it's not written in a form of x squared plus x plus c. So like x fourth to x squared, or x to the eighth time x fourth. There's some crazy ones there. No, it's got to be written in a different format, which this equation does a pretty good job of doing that. So now we have to find the other solutions. Given one solution, we're given one solution. Recall that that you can find solutions of an equation by putting them on your graph and then using the second calc 0 function. But if we don't have that option available to us, if we don't have the ability to look at zeros on a graph, then what we're going to want to do is use a couple theorems to help us out. And the first theorem that I want to cover, and this is the purpose of this lecture, to go over these theorems, are complex conjugate root theorem, which basically states that if you have a conjugate number, a complex number, as one of your roots, then the conjugate of that complex number is also a root. So basically, it says that, well, complex roots come in pairs. So if 1 plus I is a root, then 1 minus I has to be a root. And this also holds true for radicals. As you saw in the previous example, radicals basically are imaginary unit I, only they don't turn into negative numbers. So a lot of the same properties will apply there. And this is just one of them. Now let's stop and think. If we can find these two imaginary roots pretty easily, then all we should really have to do is just put this equation into our calculator and calculate our second calc 0 our way out of this baby. But the problem with doing that is, while it would work, let's say I had x to the fourth as the leading term. That means that by the fundamental theorem of algebra, there should be 4 solutions for any polynomial that results from that. And technically speaking, since they come in pairs, all of them could be complex numbers, and we can't figure out complex roots on our calculator. So there should be a way for us to systematically find all the roots of an equation, and there is, which is why we do this. So if these are solutions, then they can be written as factors. So they can be written as x minus, and then this factor will be 1 plus I, and they can also be written times x minus 1 minus I, x plus I, 1 plus I, 1 minus I. And then a third factor, because there has to be 3, because of the fundamental theorem of algebra, and it's going to be real. It's going to have to be real, because it can't be imaginary, because there's no more pairs to be formed, so that doesn't follow the complex conjugate root theorem. A lot of crazy names there, but what we're going to want to do now is, we set that equal to that, because that's basically what it is. It's just It's just like an expanded form. Now what we're going to want to do is, first things first, let's try to simplify these. And I'm going to put these on my calculator to make this easier. So I'm going to go negative parenthesis 1 plus second I. That becomes negative 1 minus I. Well, what does that really do? I don't really know why I did that. But x minus 1 minus I. It just helps us solve this out a little quicker. And we don't need that parenthesis anymore because we've distributed the negative. It's just helping us distribute the negative easier. So negative parentheses 1 minus second period and parentheses enter. And that becomes x minus 1 plus I. And lastly, I'm sorry for the cut there, but x minus c is going to be our last root. And we're not going to worry about that, though. So now let's multiply these two out. I'm going to put this on my calculator to make it easier. Oh, we can't do it on a calculator. How about that? So that's why they taught you how to do all these things, because for situations like this. How about that? Now, let's do what we have to do. So first things first, we're going to want to multiply x times x squared. We're going to keep these numbers, for the most part, the same. Next, x times negative 1. It's going to become negative x. And then lastly, x times I. So we're going to do ix. Next, we have negative x. Another negative x right there. Then we have positive 1, which is going to go in an entirely new thing. And then we have negative I. Sorry about that. Like I was saying, then we have, oh, why did I erase that? We have, let's see here, x squared, negative x times I. Then we had negative x, positive 1, and then negative I, which doesn't go over here because it doesn't have xi in there. Now we have our last terms, negative xi. Then we have negative I again. We have what? Well, sorry, let me put this in my new row. Negative x over I. I apologize. Negative I over times negative 1, that becomes negative I. And then lastly, negative I times positive I becomes negative I squared, which just becomes positive 1 because I squared is negative 1, opposite of negative 1 is positive 1. Let's divide this all out. So then what we're left with now is x squared minus 2x. These cancel. I made another mistake. I made another mistake in my calculation. I'm extremely sorry. That was very sloppy all over the place. Well, these i's do cancel because this is negative I times negative 1, which becomes positive. So these cancel. Then all that's left is plus 2. Sorry again for the abundant cuts everywhere. I've been making a lot of mistakes. I really apologize. I'm trying to rush through these. So this becomes next x squared minus 2x plus 2. Because the 1 right there gets added to that one, and that becomes 2. So now what we have is we can rewrite this as, let me see if I can just drag that down. Drag this equation. Yep, we can. This is going to make it a lot easier. Let's drag this equation down. Let's drag this equation. Let's just group this. Drag this equation down. And then let's just modify it as we will. And let's not use screen. Times x minus c should equal, well, I'm going to get rid of this because that's pointless to have the two y equals, because these should equal each other. I didn't feel like writing them, just trying to save time, which I think I did a pretty good job of. So yeah, this is the equation that we got. So it's basically the previous stated one, the previous factored one, only we've simplified this. And now what we're going to want to do is we're going to want to divide that entire thing by x squared minus 2x plus 2. And that answer should be x minus c. And to do this, we're not going to do synthetic division or anything like that because we can't. So what we're going to want to do is long division. And I understand long division is kind of long since taboo, and you get the pun there. But the point of using long division is to escape some synthetic division situations that arise if you do if you do the other way, which is to take one root and then divide it out by the entire thing over and over and over again, you can do it, but the resultant just craziness that will ensue, like the amount of possibilities of mistakes is endless. I find this to be a lot of an easier way. A synthetic division itself is just supposed to be a shortcut, but you don't want to do shortcuts if you have a chance to make a lot of mistakes, and this one actually works out to be a lot quicker and a lot easier. So now first things first is we're going to want to multiply something by x cubed to get x squared. Well, we just got to multiply by x. Just one x will be more than enough to get rid of that. So we're going to put x over here. So then it becomes x squared. Becomes x squared. That becomes x cubed. And then that becomes negative 2x squared. And then that becomes plus 2x. And then we're just going to want to subtract this entire thing, which means x cubed minus x cubed is 0x cubed. So we're going to want to get rid of the x cubed. 8x squared minus negative 2x squared. That's like adding. Minus negative. 8x squared minus negative 2x squared. That's positive 10x squared. Negative 18x squared minus positive 2x squared. So that's negative 18x minus 2x, which is going to be negative 20x plus 20. Now we have to find a way to multiply. We have to multiply 10 because 10 multiplying by 10 will give us the proper way to the proper way. I have to do a better job of explaining. Positive 10 will give us the ability to completely cancel this out. So that becomes 10x squared. 10x squared. 10 times negative 2 is negative 20 x squared. And then that becomes positive 20. So then to subtract that, what we're going to want to do is 10 minus negative x squared. That's 0. That cancels. Negative 20 minus negative 20. That cancels. And negative 20 minus 20 also cancels. So we get 0. So then this becomes our solution. In other words, x minus c equals x plus 10. So to solve this out, we're going to do minus x. This cancels. Negative c equals 10. So c equals negative 10. In other words, our other solution is negative 10, or our factor would be x minus 10. So now let's just figure this about what we did. We had one root, and by the complex conjugate root theorem we had the other one. So we just multiplied those two factors out to get an equation, and then we knew that if we multiplied that by this factor, we'd get our polynomial. So we just divided by it. We did long division because it would be a lot easier than the synthetic division required, and then we got that our equation was x minus c equals x plus 10, solved for c by subtracting x on both sides, canceling, negative c equals 10, c equals negative 10, or our root was that x plus 10. So then our last root, therefore, was x plus 10. Now that's basically all we have to do in as far as complex numbers are concerned. We've solved a lot of them out. So in the next tutorial, we're going to move on to rational functions. See y'all later.